Alright, hello everybody. This is just only a quick introduction. So welcome to Ruby Tuesday. This is our third session of Ruby Tuesday. My name is Nguyen and I am a co-organizer for Ruby Tuesday as well as a part of Nimbo team who is the main sponsor for the event. Just a quick introduction for those of you who are new here. Saigon Ruby is a community for people who love the language of Ruby. And what we would like to achieve is an active and sharing developers community. So we are holding the Ruby Tuesday once every 2 months on the first Tuesday of the month. So we will have the next one in February. And to have this event active, we always count on first your participation. We really appreciate that. And second, to our sponsor, Nimbo and also Raksul for your generous sponsorship. And also we are always looking for speakers to be joining us. There are two ways that you can join us as a speaker. First is a talk, which is a 20 minutes talk about what topic that you're passionate about. Or you can prepare a lightning talk, which is about 3 to 5 minutes. It's short and you can practice your presentation skills. So if you're interested in participating, please contact me and we will discuss more about it. All right. So for the schedule for today, we'll have 2 talks, and in the middle, we will have a small Kahoot quiz to test your Ruby knowledge. All right? Okay, so without further ado, I would like to introduce Long, where are you?
Yeah, Ryan.
Long, who is our first speaker for today. All right, please welcome me.
Hi, everyone. Just a second. So, hi everyone. Thanks for joining me. I'm Long, a software engineer from Singapore. So, it's my honor today to have a talk. I would like to share to you guys about a topic which is named Enterprise on Rails. So, I want to talk about how Nimble build an API application for large enterprise, which is the one. The one is the biggest loyalty platform in Thailand, with about 17 million users, or 25% of Thailand population. So basically, they have mobile app, Android and iOS, and also web app, in which it allows the user to grow for the reward, so they can use the loyalty point they accumulated by using the one services and store. So they accumulate the point and they can use it through the app. So the agenda today, I would like to cover 4 topics: the application features, the application architect, and the DevOps, and infrastructure, and the last thing is the key learning after we implemented this project. So this is us, D1 API. That's the API gateway we built for D1. We also build the app, but within the today's topic, we only cover the D1 API, which is focusing on Ruby and Rails. So the application features, so we build the one API, which is consumed by several clients, including the mobile app and the web one. And we build it at an API gateway to interacting with and our gateway interacting with the several upstream API. And we almost don't use any database, since all the critical data lies in the third parties. And we also have to exposing a consistent API for the client, following a strict JSON API spec. It's also utilize the full text search for searching the content, including the rewards and the article, which means kind of content for on the app. In terms of interacting with multiple upstream API, each one of them have different standard and convention regarding the response, naming, pagination, authorization. So it doesn't make sense to for the client to interacting with that different upstream API gateway. So we act as an API. I'm sorry, it doesn't make sense for the client to interacting with the upstream different upstream API. That's why we created an API gateway to handle all the complexity. So but besides that, we also need to apply some business logic on the return data from the upstream in most of the cases. And in some screen, the requirement resulted in several upstream API calls. So we also implemented the parallel request to better to serve a better response time. I mean. So this is the application architecture. So as you can see on the left, give me a second. Right here, since we have different upstream API, so we group all each of them under a folder under the library directory. We create the client class. It's just a wrapper to interacting with each of the upstream API, and we add those client classes under auto load and eager loading, so it's ready to use. And we also utilizing the object memorization for the connection, so it can be reused across multiple requests. We also isolating the each of the how can I say the scope of the API into different engines. It isn't necessary each of the engine belong to a separate upstream API, but we just try to isolating the scope. Like as you can see here, for example, the point containing of the API endpoint for the point related API, and the reward containing of the API endpoint for the rewards. And yeah, as mentioned, there was some time we have to implement parallel request. Why? Because as you can see, for example, on this screen we have to we have to show a list of batches for the user, but each of the batches we also have to show the progress. But to fetch the progress of each of the batches, we have to call multiple API. We have to make multiple API calls to the upstream. So if we leave that job to the client, so the work has to be repeated between each platform, like iOS, Android, and web. So after discussing with the mobile team, we decided that we need to handle that all those logic from the backend, which I mean on our API gateway. So it means a single API request to get a list of batches from the client, resulting in multiple upstream requests made from the API gateway. How did we do that? We underneath we simply utilize the multi-thread setup of Puma web server. So some requests which doesn't depend on each other can be run on parallel. So in case of the example I just talked about, like first we trigger an API call to get a list of batches, and then for the progress of every single batches, we can do the request on parallel to set the time. So we evaluate some the Friday adapter which support parallel request. As you can see here, we consider M HTTP, M synchrony, and type peers, and we did some benchmark to see which one is the best, and it looks like type peers is the brightest candidate, and we choose it as an adapter for Faraday. So basically, to make several API call in parallel, the code is look like this. Sorry. We simply trigger several API call. The retrieve method here, actually, it will call the get method in which it again call to the upstream, and we can define the connection to a single upstream using this method. But as you can see, with this definition, every request has to create a new connection. So as we use the same configuration for each request to the same upstream, it makes sense to memorize the Faraday connection to send between requests, right? Sorry. So we can just memorize the connection object here, so it can be shared between requests to the same upstream API. But what would happen if the connection was being used by multiple threads at the same time? From our own experience, following this implementation, we saw that when we making parallel requests, when there was a case that one of the requests failed, and it caused some data from one request leak to the other, and there was some unexpected behavior. So how did we fix that? Instead sharing the same connection between all the threads, we come up with a solution to create a separate connection for each thread. Here, and if you look at the code, like for every thread, we will initialize a new connection for that thread, so you can avoid that situation. And in terms of the DevOps in infrastructure, our API gateway run on AWS using several various services on the AWS, including the ECS for deploying the Dockerized application to EC2 instance. In terms of ECS, we are using ECS with EC2 instance, not Fargate yet, and ECS is also set up for auto scaling. So when there was a time when if a request is high enough, it will automatically scale out. For example, in the flat day, or there was some time they open up a new campaigns which attract a lot of users. We use Terraform, even though we use various AWS services, but we don't create them manually. It doesn't make sense to manage all those services by hand, so we use Terraform to manage and define all the infrastructure as code, and we use them for CI for CI/CD. Of course, there are a lot of options out there, but at Nemo we are using Semaphore for most of the project we are working on. We also use Amazon Elasticsearch, the managed services by Amazon for supporting full text search. And on AWS, there's not only us, Nimble, but there are also other third party accessing to it. So we relying on AWS. I am for managing the access. This is the how it look like, the infrastructure. We have all the EC2 instance on ECS, staying inside a private subnet. Is all the traffic coming from the public. Oh, sorry. We go to a load balancer. We go to through an application load balancer, and then the traffic will be distributed to the EC2 instance. From the EC2 instance, it will connect to the Elasticsearch cluster for the search ability. Besides, there is also Redis for caching and database for some data. As I mentioned, most of the data lie on the third party, but there was some data we also had to store on our own database. And we use CloudWatch for logging and monitoring. Regarding Terraform, to define and manage the infrastructure as code, this is how it looks like in our projects. We modularize the whole infrastructure into smaller modules for easier management. As you can see here, like we create a Bastion module for create a Bastion server, so we can access to the EC2 instance through it. The database module, ECS cluster stuff. The same thing happened for other AWS services we are using. And for each of the environment, including the production, SIT is kind of similar like a 90 or staging environment. We create a separate folder for each of them, and in this folder, for each of the environment, we call the module predefined module here with the to create a environment infrastructure for that environment. This is a lot of code, I know, but I just want to give you an insight how it looks like. This is you don't need to care about every single line of code here, but this is one of the modules. For example, the ECS cluster, we will define it here. So basically, the infrastructure for every single environment would be basically the same, except the configuration, like the type, the instance, yeah, like that. And from on I'm sorry, and when defining that module for every single environment, we will pass in the parameter to create the infrastructure as we need. So the accomplishments, our accomplishments, we managed to implement RESTful API using the best practice, and we also managed to abstract most of the complexity of the upstream API from the client, and we handle the we are able to handle a high traffic API gateway with our dedicated DevOps team. The whole infrastructure was managed as a code, and from our work experience, some of our developers prepare and got the AWS developer associate certification thanks to that project. So our takeaway is that the developers should learn DevOps. That's from our experience. Hope that helpful for you. Yeah, basically that's it. If you have any questions, just write.
Can you show the slide primary request with Nguyen?
Sure.
I see.
Just a second.
Yeah,
This one, right?
Yeah, I have a question on the Booman thread.
Yeah.
Yes, and I know we have we have the Booman thread 1.2, thread 3, and how to distribute. In, I see the your application.
We have
You distribute the thread 1 handle some request, and thread 2 handle some request, right?
Yeah. In fact, a thread will handle one request. So, for example, if we are calling 3 requests in parallel, for example, in our case, we use Puma and in a code. Puma is a web server, and in a code we are using Faraday for managing the connection. And to support parallel requests, as mentioned, we use Typeus. Just a second. Typeus is one. We we use this. There are several Faraday adapters which support parallel requests, and in our project we use Typeus. It will manage and distributing the requests between the threads.
Yeah.
Does that answer your question?
Yeah, I got the keywords. Yeah, but I didn't use time time box.
Yeah. Basically, you can look for it.
Yeah.
Yeah.
I have questions.
Yeah.
So basically, in order to return and respond to the user, so that the request from user have come through many companies. So if a user asking or someone asking that my request is too slow, so how do you diagnose the problem?
Again, please. Again,
so
please.
if an request reported is too slow because it goes to many services. So how do you, if you got and report it like that, how do you diagnose the problem? Which service causing the problem?
Well, as mentioned, we are using AWS CloudWatch for logging and monitoring. So every single request coming from the client will be logged. Like we will log the request from the client with the endpoint and the parameter, and then we also log the upstream API request we made to the upstream. So we log it from the beginning to the end, and of course, when the client is issuing an API call, then we have to make one or several API calls to the upstream, and we also log the request we made from to the upstream, in which it records how much time it took to handle that request, and the total time it took to handle the request from the moment the client is issuing that. So in case an request it report that as slow as you mentioned, we can relying on the log to investigate. Does that answer your question?
Yeah, got it. But do you have any like software or dashboard to proactively monitoring the systems?
Yes, we do. We do use New Relic for application performance monitoring. So there was some time, like as I mentioned, there was some special day which are the one the app they have special campaigns and with a lot of users come in, and yeah, we did experience that. There was some time out and delay, and from New Relic we saw which is the bottleneck.
Got it.
Any other questions?
I have.
Yes.
So, were you facing the high memory issue with Ruby when you create many threads?
Okay. High memory when
Yeah.
you're using multi-threading?
Yeah. When you create, like you say that one connection in create one thread to handle it, right? So it will be create many threads, and in Ruby, I see I hear this the issue is if you make high so high memory.
It hasn't been an issue we experienced so far. So when there are too many connections, as you say, and it results in high memory usage. Our infrastructure will be automatically scaled out, and more EC2 instance will be added in to handle. So we haven't experienced any performance issues so far. But we did see some performance issues for the upstream API. I mean, so our API gateway is fine. We can handle as many requests as needed. But when we send it to the upstream, it causes some timeout for the upstream. They can't handle all of them. But I mean, in the scope, our API gateway is all fine until now. Yes. You have a question, right?
Okay. So, how do you achieve the deployment about the DCS service? Are you using code pipeline or code deploy for?
No, we are using a third-party service named Semaphore CI. Many of you may heard about Travis, or maybe you can use Jenkins to manually manage it. But we use Semaphore CI, and then we deploy. We do the integration and deployment there using it.
I see. Do you have any reason why don't you use AWS deployment tool like code deploy?
Why don't we use a code deployer instead of this?
Yeah, because I think so as long as using everything in AWS, so we can manage easily.
Actually, we are experimenting it. I mean, switching from Semaphore CI to code deploy and code pilot. We are having an internal project, a small one, and it's kind of hackathon at Nemo. We are trying to evaluate it. But at Nemo, we are using Semaphore CI for most of the project, and I think for the consistency purpose, since everybody know how to use it, so we will still using it until now.
Thank you.
I have a question. So I know you use Parallel to manage an open thread, right?
Yeah.
I don't know this library can manage the connection good enough. So if the thread is failed, it so cause the list of connection to the database. So how the I don't know how the Parallel manage the thread to avoid causing the connection list to the database.
I don't really get your question. Like, do you mean that in case of several requests?
So in case we open the connection, it's failed. So it can cause the connection leaking to the database, so it doesn't release the connection.
No, connection here mean the HTTP connection to the upstream API service. It doesn't mean the connection to the database. We don't connecting to the database directly, because as I mentioned, most of the data lie on the third-party service. I get an API gateway to call to other API to handle the job.
Yeah, just like FTP connection. Right?
Yeah. It's not a database connection directly. I think that's it. Thank you.
All right, thank you.